Hello all. Today in this class we discuss about Internet Protocol version 4 or IPv4, different types of IP addressing mode. So first of all, this is a classless interdomain routing, that is classless interdomain routing protocol, which is also named as CIDR. Okay. So first of all, there are 5 different classes are available. In a class A, the IP ranges are from 0 to 126 and default subnet mask is 255.0.0.0. For class B, starting from 128 to 191, because 127.0.0.1 is known as, yes, right, this is for the loop back test. Okay, this IP address is used to check the NIC card for a Ethernet connection in a computer, and the default mask is 255.255.0.0. So default subnet mask is very important for subnetting in the later we discuss about the subnetting concept. And in a class C, the IP ranges are from 192 to 223 and default subnet masks are this, and for class D and class E they are not available and the IP ranges are from them. So what is 0 and 126? These are basically the decimal formation of binary representation. Okay, so 0 to 126 means there are 8-bit, there are individual ones and zeros are depending on the different types of IP ranges. So let us discuss first about what is the concept of subnetting in the today's class. So basically dividing a large network into multiple small network is called the subnetting concept. So basically in our one cluster there are many different networks are available, and for assign different types of IP address. So this is the concept of subnetting concept. The whole, say, this is called the network, and in this network there are cluster of network are connected to each other. So how subnetting is done? There is some concept for a class A addressing. So we first of all discuss about the different types of class. So for class A, the number of network bits is defined by this /8. That means here for class A we know that our default subnet mask is 255.0.0.0 and IP address range from 1 to 126. And one thing should be remembered, that here first 8 bit are known as network bit and other remaining 24 bit are known as, yes, right, host bit. Okay, so these are structure. Now for class B, the CIDR /16 means the network bit are 16 bit and host bit are 16 bit, so they are equally partitioned, and default subnet mask is 255.255.0.0. okay, now coming for class C. Class C, here 24 bit for network bit, so they are 8 bit, this 8 bit, this 8 bit, total 24 bit are for the network configuration bit, and remaining 8 bit are known as the host bit, and default subnet mask is 255. Why this is 255? This coming at 255 because you see that here 8-bit network. So if the highest bit possible is 8 ones, so what is the binary form of 8 ones in the decimal equivalent? 8 1 means in a binary form. What is the decimal equivalent? Yes, right, 255. So that's why this 255 is .0. Why 0? Because the host bit are remaining part are 0 0 0 0 0, all are zeros. But look, in the class B there are 2 network bit, so that's 8 and 8. Therefore here 8 ones and here another 8 ones. Therefore this is 255, this is 255, that is 255 here, and 2 0 for 2 host bit. Okay, now coming to the third point, class C, there are 3 network bit, 3 into 8, 24 bits are assigned for the network configuration. That's why you have 255.255.255.0. okay, so now one example is created here. See our IP address 192.168.10.0 and 24 is a network bit. So default subnet mask is that. So depending on this bit, look in this bit, we can recognize our class. So if here 16 is mentioned, here 16 is mentioned, then therefore it is class B. CIDR interdomain routing facilities are used here. Okay, so basically in a network IP assignment the 24 network bit are used, and therefore that here the binary assignment are shown 2 to the power 0, 2 to the power 6, 2 to the power 7. and the whole bit we summation this bit equal to the decimal 255, 255, 255, and this is a host bit and this is a 0 bit. Okay, now clear it. Now one thing, another example for now. Our IP address is 192.168.0.10 and here refer 25. So what is the meaning of 25? We already know that 24 means 888. There is 3 into 8, 24 bits are assigned, and one extra, that means 25 means 24 plus 1. So where is the 1 is coming? Now we take this 1 from the host bit. So this is a key of this routing of this IP addressing. Okay, these are very important. So if here 26, then we here borrow 2 bits. So now here look at that, here 24 bits and 1 borrow from this bit. So what is the power of this bit? So this is a 2 to the power 7, because this 2 to the power 0, 1, 2, 3, 4, 5, 6 is a 2 to the power 7. So that's why. What is the default mask? The default subnet mask is 255. 255 because 8 ones means 255. Another 8 ones means 255. This is 255, but here this 2 to the power 7, that means 128. So this is default subnet mask for this classless interdomain routing. That means 192.168.0.10/24 25. Okay, so now here how many number of network are possible? So here we see that our borrow bit, the formula is total number of bit borrowed from the host n. So how many bit are borrowed? Here 1 bit are borrowed. Therefore 2 to the power n, this 2 to the power 1 into 2. So therefore 2 network are possible for subnetting. So basically large network is divided into 2 network, because 2 to the power n, 2 to the power 1 equal to 2. So IP address number 2 to the power n, here n means the total number of host bit. So what is the total number of host bit here? 1, 2, 3, 4, 5, 6, 7 bit. So 2 to the power 7, 128 IP address are assigned. Okay, and actual how many hosts are possible, because there are 2 IP for the network and broadcast. I will discuss about that. So now the formula is that 2 to the power 7 minus 2, actually 126 total IP address are assigned, because one is one is assigned for network ID and one is assigned for broadcast ID. So what is that? So now our starting IP address is 192.168.10.0. So this is basically the network ID. So this is the first ID which is not given by any host. So the next IP address, so from 1 to 26, this is assigned for host, and for 192.168.10.127, this is basically known the broadcast ID. Okay, so how we divided that? Because we assigned that there are 2 network are possible, so that's why here 2 network are possible. Okay, so now see that here our formula is that, so here 8 bits are possible. So therefore 2 network means one network is for 0 to 127 and another network is again network ID 128, and 129 is for given for the specific host, and 254, and this is again the broadcast ID. This is a broadcast ID. So we see that one large network can be divided into 2 subnetwork. That's why this is called the subnetting. So here using this IP address and using this using this IP address and using this 25 bit of the network bit, we can configure our network into 2 subnet mask divided into 2 subnetting. So this is our network 1. So this is our network 1. Say for office 1 or any office or any college, their own network. This is a network 1. The corresponding IP provided are there, and this is a IP for the network 2. So this is the should be very clear in mind, because otherwise when you distribute your IP address in the host, different types of host for the static IP, then subnetting concept is very nice concept to distribute the IP address from the main network. So now one example that now for the same IP, if this network bit is 26 bit, then what we'll do, now see that here 888, that means 24 bit, and here we borrowed from the 2 bit. So here borrow 2, that means 4 subnet are possible, because the formula is 2 to the power n, here n equal to 2, because here we borrow 2. And one thing should be remembered, that this is a 2 to the power 7, that means 128, and this is 2 to the power 6, that means 128 plus 64, that is 192 total summation. So that's why the default subnet mask is 255. 255, 255 and 192. Okay, these are 192. Now 4 networks are possible. So total IP address assigned to the power 6 to 64. Why these are coming? Because this is 8 bit, this is an 8 bit, and minus 2 bit, because 2 bit are borrowed for to configure the network. So remaining 6 bit are possible for the host configuration. So that's why to the power 6 to 64. But actually there are one IP assigned for network ID and one IP assigned for broadcast ID. So therefore 64 minus 2, that is 62 IP are available for the each network. So coming to the point, so for our first network, these are starting IP address, these are broadcast IP, and these are these are network IP, these are broadcast IP, these for network 1. Each network contains 62 IP, so there are 62 IPs are assigned. Then this is starting from 64 and ending 127. These are network 2 mentioned here, and then starting from network 3 128, and the last IP address, broadcast IP address, is 191, and next one the network ID is 192, and last is broadcast ID for 255. So these are network 1, network 2, network 3, network 4, our 4 network. So different types of computer and host. Say for the 192, so for the 192.168.10.0 if 26, they are assigned 4 network 192.168.10.0. so from one network is starting from here, and the last IP address assigned for 192.168.10.63. so this is for network 1. So basically these are consider these an office. Just look like that. I draw some diagram of office. This is for the office network. Okay, and the next IP address assigned for 164 to 127. So the next 192.168.10.64 to, these are basically network ID 168.10.120, yes, 127. So say for this is for any other building, for other building in a city. Okay, this is either bank or any commercial sector. So this IP is assigned for this. So different types of IP, and the lots more IP are generated from the single classless entitlement using this classless class C routing protocol, or also known as CIDR routing protocol. Okay, so this is the concept of subnetting. So here for 25 network bits, basically class C is basically all where use class A and class B is for the some special purpose uses, but in our today's home broadband services, basically 192.168 are basically provided, and 172 basically class C are basically important than others, because the class C range is from 192 to 223. Some network broadcaster also provide class B IP address. Okay, depending on their configuration of the network. Okay, so this is a subnetting concept. So what is the meaning of subnetting? Subnetting is basically the dividing a large network into multiple small network, and if we subnet the network, then cyber security and using the security protocol also increases. The later video will discuss about how the network security will be increased using the subnetting concept. That's all for today. Thank you.